Alright, making this video partly because I wanted to info dump about something I'm interested in, but also to try and make sure I actually follow through with this project. Cause, well, I've never actually finished a single programming project. Ever. Anyways, hey people, it is I, Poets, and welcome to my first YouTube video. Well, for the 9th time. This is a devlog on a project I've recently started, and please understand that I have no fucking clue what I'm doing. Well, this is my first project in Odin, which is my second programming language after Python, and I guess GDScript, so third, which they're so different from Odin. Like, I've never cared about the concept of memory before this. Everything is so new. I've also only heard of this language around like 3 months ago and only started learning it last month, so don't listen to shit I say here. This isn't just a warning, I'm saying this because I'll be spitting some bullshit. So what is this project? Well, it's a terminal emulator, because I thought it'd be an easy and quick first project to learn the language, right? I mean, just put a few text on the screen and let the shell do its thing, right? Right? But what is that? Well, if you're a based Linux user, you've probably used one at least once, and if you program, you're likely decently familiar with your terminal / console / whatever you call it. I'm not gonna get into the terminology because that's a stupid thing for me to do. Whether you use what came with your computer, like Mac terminal, Windows terminal, or GNOME terminal, very creative naming, guys, or you're cool and use stuff like Alacrity, Kitty, or Western. Well, a terminal is a device. It's a very old device used to interface with a computer. You know, for basic input and output and such with the shell. A big chunker, if you will. I don't know much about them, so I won't keep talking about them, but you clickety-clackety on the keyboard and you get text on the screen. Simple. A terminal emulator is a software program to emulate that. Quite some people confuse the terminal emulator with the shell, but basically the terminal is the interface, so the input and output, putting things onto the screen and such, while the shell is what runs inside the terminal. Anyways, so how do we build one? Well, termems, which is what I'm calling terminal emulators now because I'm a little lazy goober and you don't want to see the outtakes of this video, they're very operating system specific, and I've chosen to do Linux because while I use Linux, and it also happens to be the simplest because of the existence of pseudo terminals. A pseudo terminal is a pair of device files on Unix-like operating systems, which, well, does everything for you. Freaking great's what I tell you. In a pseudo terminal device pair, you have a master device and a slave device, and from what I understood, the slave device is what your shell or whatever program it interacts with, while your termem can read and write to the master device. And that's it. So let's do it. I don't know why I'm shaping this like a tutorial. Please don't follow this. I have no idea what I'm doing. Anyways, the plan is simple. Step 1. Open the device pair. Step 2. Set up the device pair. And step 3. Start a child process for the shell. Or as I like to call it, execute child in the slave device, which just sounds so wrong. Oh, and I'm not getting to this in this video, but step 4, putting text on the screen. There are 2 main ways to go about step 1 and 2, and I'm not kidding. Apparently some people have some extremely strong opinions on this. I found this absolutely hilarious while researching. So these 2 ways are between the functions openpty and POSIX openpt. Both available in the standard C library and does the same thing, but works slightly differently. So openpty is the order function. It takes in pointers for the master and slave device's file descriptors, the file name for the slave device, and some extra parameters, which each gets set to the respective values, and that's all you need to do. No more setup. POSIX openpt on the other hand came after and is, well, standardized in POSIX. Yay, I don't really care. But all it really does is it opens the pseudo-terminal multiplexer device, which for most operating systems is /dev/ptmx, which quite basically is just open/dev/ptmx and its flags. It says so in the Linux man page, it says so in the POSIX specification, and it's what glibc does. There's a lot more operating system stuff, but I'm only targeting Linux anyways. POSIX openpt comes with a few functions to set up the pseudo terminal: grant pt, unlock pt, and pts name. The process looks like this. You open the terminal multiplexer with POSIX openpt, which gives you the file descriptor of the master device. You set up the slave device with grant pt, which grants you access to the slave device, and unlock pt, which unlocks the slave device. Then you're able to get the file name of the slave device with pts name, which you can simply open with os.open in Odin. So which one should I choose? Well, this one blog post which I've been following this entire time and was so helpful in this entire journey, well, they chose POSIX openpt, but the writer said about it, I'm not 100% sure why we need this low dance. The interface of openpty feels a lot better. Well, whoever wrote this intro to pseudo terminals blog post straight up just called openpty poorly designed. But I mean, musclibc's implementation of openpty literally has a comment that calls it vastly superior, which, to be fair, seems like it has a unique implementation for it, while the same function in GNU's libc kinda just calls POSIX openpt and its subsequent setups. So what did I choose? POSIX openpt. I chose POSIX openpt, mostly because openpty seemed unnecessarily complicated, if that makes any sense. I know I implied that openpty was the simpler one and spent far longer explaining POSIX openpt, but I felt like that its complications made a bit more sense, methinks, as well as that interfacing with pointers and foreign functions in Odin sounded insane. Whatever though, they both reach the same point and I'm gonna wrap in an Odin function anyways. So I did it. I imported these functions from libc into Odin and slapped them into a proc that returned a struct for the file descriptors of the pseudo terminal devices. Yay! Now on to step 3. Remember that blog I mentioned? It straight up provides a snippet for this step. All I had to do was copy it, translate it into Odin, and bam, done. I mean, in practice it was a bit more complicated, but damn was it a lifesaver. How it works is you fork the process with linux.fork. With the child process, you create a new session group, whatever that means. Even the blog post labeled it as arcane. But it does link this other article that goes over processes and sessions, which I'll do the same in the description. But this is done with linux.setsid, which, cool story, the binding for it originally behaved kinda weird, since the syscall was supposed to return the process ID, whilst the binding for it in Odin's core library only returned the elno. But guess who fixed it? That's right, it's baby's first pull request. I mean, it's only 2 words, but I was so proud of myself. Anyways, after that you can redirect the standard streams, standard in, standard out, and standard error to the slave device. Afterwards you can execute the shell, or whatever process you like. There are a bit more to it, like some type conversions to interface with some of the libc functions and Linux's calls. I also did run into some issues with getting the environment for execve, because apparently Odin's OS package's environ doesn't exist on Linux. But fortunately, they have been working on a second version of the OS package that you can access with core:os/os2, which did have environ for Linux and works perfectly. However, that package is still work in progress, which I have experienced firsthand when I woke up one day, updated the Odin compiler, and it stopped working. I couldn't import the package because they added some new Windows specific procs to it which doesn't exist for Linux, causing it to fail on import. So I couldn't compile, but otherwise it works great. Assemble these together and you're practically done. You can now write to and read from the master device with os.write and os.read to interact with the shell, and that's basically it. We could test it by printing it out and writing some pre-written comments for the shell, and it seems to work just fine. Except for one last issue. Now read is a blocking function, and unless you want your program to freeze completely when the master device is empty, you'll have to set the non-block flag on the master device with F-control. But after that, you should be good. I simply just slapped that into a proc. Now we have the sudo terminal set up and working, but nothing to show for it. Which means it's now for the miserable part, which luckily isn't in this video. Opening a window, rendering text, and drumroll, parsing NC escape codes. Let's see how long I can keep doing this before I give up again, because as of writing the script, I have only just started it, and I'm not having a good time. So wish me luck. I'll leave the GitHub repo for this in the description if anyone wants to check on my progress. I've named it Terminal solely because it sounds cool. I had this thing with null, byte, computer reference or something like that, but it's very trivial, so whatever. And also names for termemps are usually a play on either terminal, console, or tty for teletype. And my second choice was titty, so like no. Alright, time for my closing thoughts. This definitely wasn't what I was expecting when I chose this for a project. The plan was on just getting familiar with Odin and maybe raylib for the next step, but I did not expect to learn this much about Linux, libc, and all these random stuff, which I did find interesting. Again, this was my first project with Odin. All I had done prior was a few advent of code problems, which I actually really enjoyed, but nothing else. And my first impression is that I kinda love it. Like, I am tempted to make an entire video just glazing this language. Coming from Python, programming in Odin is such a different experience compared to what I'm used to, except for the fact that they're both just fun to work with. Being a C alternative, there isn't any object-oriented programming or classes, and the creator is firm on the no. Which at first sounded like I was gonna starve. Being a class build object maxer, I cannot believe I just said that in Python, but I ended up adapting and grew to really love the simplicity of a classless language. Like inheritance, what is that? Encapsulation? Huh? Abstraction? Never heard of it. The language is really just so simple, like I would say far simpler than Python. Maybe not easy, but definitely simple. Like everything you need to know is on that overview page. It has quite a unique syntax, but in a way where it just makes sense. And lastly, the foreign import system just works really well. The hardest part was literally just some type conversion, which was expected. Of course, some stuff are still in development, whether you see that as a good thing or a bad thing. That's up to you. Anyways, that was my weird little devlog kind of thing. I may or may not make a part 2 on trying to get a window open, but I hope you at least enjoyed this one.